You know, in the world of high-performance machinery, some of the biggest, most expensive threats are the ones you literally can't see. They work in silence, slowly eating away at your most valuable assets from the inside out. Today, we're going to shine a light on them. We're going to make that invisible threat visible. So, what is it? What's this hidden danger that could be compromising your operations at this very moment? If you're responsible for any kind of high-voltage rotating machine, this question, well, it's absolutely critical. Because in your world, there's just zero room for error, right? Doesn't matter if you're in power generation, manufacturing, or transportation, the performance, the reliability, and yeah, the safety of these machines are totally non-negotiable. Everything relies on them running perfectly, day in and day out. All right, let's pull back the curtain. The threat we're talking about is called partial discharge, or PD for short. The simplest way to think about it is like a series of tiny little electrical sparks, kind of like a mini lightning storm that's happening inside the insulation of your equipment. It is the very first warning sign that your insulation is starting to fail, long before anything catastrophic happens. And this is why it is such a big deal. If you don't catch it, this silent damage just keeps building until you get one of those catastrophic, unexpected failures. We are talking about massive, expensive downtime, and even more importantly, some really serious safety risks for your people. But what if you could see it? What if you could find this invisible threat before it ever causes real damage? Well, that's where things get really interesting. Let's talk about how you can see the undetectable. Okay, check this out. This slide says it all. On the left, you've got motor windings that look perfectly fine to the naked eye, right? Nothing wrong there. But on the right, that's the same component, just seen through a specialized camera. See those glowing spots? That is partial discharge caught in the act. That's the problem, right there, made visible. So how do we see it? Well, this is the solution. This is an OFIL UV camera. Its technology is designed to do one thing, and do it with incredible precision. It detects the specific ultraviolet light that partial discharge gives off. It instantly pinpoints the exact location, turning a hidden electrical problem into a clear visual piece of data you can act on. Now, you might be thinking, this is a pretty niche problem, but it's not. This technology is absolutely essential for a huge range of industries, especially those pushing the boundaries of what's possible with engineering. Take power generation and heavy industry. For these massive, super expensive motors and generators, being able to spot PD early on, well, it means you can prevent that costly insulation damage we talked about. You can dramatically extend the operational life of these incredibly high-value assets. Or look at the EV industry. As electric vehicles push to higher and higher voltage systems, the risk of partial discharge just gets bigger. Being able to find it during manufacturing is absolutely key to ensuring the reliability and, of course, the safety of every single EV motor that hits the road. And this even goes into the future of flight. For electric aircraft, the motors have to perform flawlessly at high altitudes. But here's the catch. The low atmospheric pressure up there actually makes partial discharge more likely to happen. So this tech lets manufacturers test for and fix that specific risk, which, as you can imagine, is vital for safety. So seeing the problem is one thing. That's the first huge step. But the real value, the real advantage, is what happens next. It's about turning that insight directly into action. Because when you make partial discharge visible, you are taking back control. It means you can drastically cut down on unexpected downtime. You can enhance operational safety for your team. You can streamline your entire quality assurance process. You extend the life of your most critical assets, and you get to shift from a reactive maintenance plan to a truly predictive one. At the end of the day, this isn't just about finding a fault. It's about fundamentally changing how you manage reliability. So I'll just leave you with this one question to think about. What if you could predict failures before they ever happen?